Hi everyone, the aim of the video is to explore the reason of the digital quartz watch rush and then trying to repairment. Long story short, 4 years ago I have purchased watches from Chinese marketplace for less than $9. This is a Skmei, brand name Skmei, and the model is 1068. Really cheap, crazy cheap, and very useful. It has big display, like you see, very contrast, and with big numbers. And on the display present data, day of the week, month data, and running the seconds. So nice, I like it. Very simple and daily watches, so I like it. It served for me 2 years without any problem. Afterward, I investigated the watches begin to rush, and now we are going to understand and we will try to fix it. Okay, let's see. But first, let's disassemble it and see what's going on inside. This is the back cover. Buzzer. Again, we don't need it. This is a electronic unit. Also, we don't need the housing. Ta-da! This is how this look like. Maybe, here is more good position. Not so bad. It's looking good. Good plastic. So let's continue. Next step, let's remove the battery. Oop. Oop. We don't need it anymore. And next step, it's a 1, 2, 3, 4, and 5. Up. Previously I made these 2 holes to measure in the frequency of the quartz. I made some investigation before, so these 2 horrible holes is my job. I like it. Plastic made is very well. It's not something soft, you know, it's pretty hard. And shape is looking good, really good. Okay, we don't need it. Next step, it's push button contacts. No. Electronic is here. Boom. Nice. So display. This is electronic PCB. Oh, no focus. Where is focus? Okay, I want to change some settings in my camera because I can see it's not in a focus. Alright, now we're in a focus and we can see much clearer what's going on and how it's made. So on the back side, nothing, just contact pad for battery and spring. This is for buzzer. So next step, oh hold on, I missed something. Need to be very careful. This is a contact pad for the backlight, and second one is here. Oops. Alright, Let's see on the PCB more clear. Again, no focus. What's going on? Ah, better. So here is, we can see the crystal quartz. It's here. So we can see a buzzer transformer. Then step up DC converter for the backlight. It's here. And a couple components, transistor probably. Yes, it's nice. Very simple, very nice. And integrated circuit. Very beautiful. Name of the PCB or module is LR3501. I don't know what it means. Probably later I will try to find something in Google. Okay, so what we see here, this is a display, so we don't need this one. Second one, contact pad for the backlight, let's leave it here. One and second one. Now let's see the display. Oh, again, not in the focus. Very nice. I like it. This is a fluorescent backlight plate. It's interesting. Okay, let's put back all components, put back the battery, and try to measure the frequency of the quartz, because this small component crystal quartz, it's a main component which one creating the frequency, and only this one guy making accuracy, good accuracy for the watches, crystal watches. Alright, let's put back every component. So now movement, assemble it. Let's put inside the battery. And next step, we need to add, hold on, the cover, and last one, screw, very tiny. Oh, not working. Why? Oh, can't believe it. Ah, okay, I know. Problem is here. Let's screw it a little bit tight. Now, good. And we're ready. The next step, it's make some diagnostic or measurement of the frequency of the quartz. So we see unit looking good, no water inside, no dust, no mechanical damages. So I guessing problem in crystal quartz. I don't know what happened. Maybe I hit the watches, maybe something happened. I don't know. So let's try to measure the frequency of the quartz, and then we will see what's going on and trying to provide next step of the repairing. Here is my home setup. Yes, it's all what I have. So before we will do some job or some measurement, couple words about this setup. It's very complicated to do this job because environment is very noisy. Electromagnetic noise is so huge, and it's complicated because signal is dirty and the measurement is a little bit wrong. So I made some simple modification. I'm at the ferrite choke between oscilloscope and frequency meter, and I'm at another two chokes. One is here, this is the end of my probe, and one is here, this is the beginning of my probe. I'm using the active probe to pick up the signal from crystal quartz, and this is a battery, it's a power supply for circuit, which one is for amplifier, which one located is here. So a couple words about the unit, watch unit. Crystal quartz unit, crystal watches it's a very sensitive unit or device. I'm talking about the signals between integrated circuit and between crystal quartz. It's a very poor signal and very sensitive to any another signal from outside, electromagnetic signals. And what I wanted to do, I want to pick up the frequency or the signal directly from the crystal. And probe has input resistance and input capacitance, and of course this is harmful for the crystal quartz. So then higher resistance and lower input capacitance, then we destroy or we will get the signal more correct. So let's try to pick up something and see what we have and how we can play next with the numbers. Okay, now we are ready to pick up the signal and see what of the frequency was generated from the crystal quartz. This is my extremely horrible idea how I can do this. Screwdriver with the alligator clip and with metal plate, metal tray to reduce the electromagnetic noise from outside. Additional resistor with 10 megohms resistance. Alright, let's try. Signal still dirty. It's still bad signal. But frequency 32 kHz, 768 Hz, and 300. It's wobbling. 310, 328 to 328 again. Probably. Oh, my bad. Sorry. A bit more complicated. Hold on. Probably something like this. Let's see closer. So it is what it is. Now we have frequency, and to understand, is this too big, too high, or too low, or it's okay, or it's not okay, we need calculate. Okay, we need to switch to mathematic, and then we will see is this good or not. All right, let's do this. And now final part, and it's most impressive for me. I made some calculation to get the answer on my question. It's a little bit crazy, a bunch of the numbers and a couple pieces of the papers to see what's going on and what I have. So here is input data. Its original frequency 32.768. Next numbers, this is frequency of the my unit. Second numbers, this is how many seconds we have per 30 days. Everything is here. I get these two numbers, two answers. First one, this is a ppm, part per million. Second one is SPM, second per month. So my unit giving me 10.3 ppm and 26 plus 26.7 seconds per month. In the internet I found the information, the best regulars crystal quartz for watches can give you 5 ppm. It's mean 12.9 seconds per month. So my result is not so bad usually, actually. This is a super cheap crystal quartz watches, and it's not something like a very accuracy and something like this. Another moment. It's okay. Every year, crystal quartz can lose the accuracy or can drift a little bit from original frequency. For this day, this watches is 4 years old. So in the beginning it was probably very close to these numbers because accuracy really was amazing. It was really good. It's just something like from 3 to 5 seconds per month. I think it's for $9. It's amazing. For today it's 26.7 past the 4 years. And next step, probably in the next video maybe, I want to try to swap the old crystal quartz to brand new crystal quartz with the 5 ppm accuracy and low temperature drift or low temperature coefficient. It's dependent from temperature, crystal quartz can change the frequency to higher or to lower. Alright, it's done. Test is complete. And thank you for watching, thank you for your time. See you in the next time. Bye.